All right, before we even start talking about the form, the equation, what it looks like, the key features it gets, I want you, like I said, draw this little sketch of a parabola. You don't have to put the grid on there. You could just do the graph and the axes and label all these points. All right, so we've learned a couple key features. What are a couple key features you want to tell me right now you could see on this graph?
The y-intercept.
Good, y-intercept, vertex. What else do we see? AOS. What's one more thing I haven't heard yet? The roots. The roots. So we're going to talk about the roots right here. Okay. What is another word for roots? X-intercept. So give me an x-intercept there. 3, 0. Whoops, wrong thing. 3, 0. 3, 0. That's that coordinate right there. What's the other one? -1, 0. All right, so roots are also known as x-intercepts. Okay, and they're also known as zeros. That makes sense because what's the y value for an x-intercept? It's always 0. That's why they call these zeros. Okay. Another thing that they will call them in a few weeks when we start solving algebraically for roots, we'll call them solutions. Solutions to the quadratic. Solutions are just zeros, x-intercepts, or roots, same thing. 4 different ways to say the same thing, the same key feature. All right, let me show you the equation of this graph. Write this down too. Y equals, let me show you the standard form first. It's going to be x squared minus 2x minus 3. Would you agree that could be the equation? How could you argue that it is? The y-intercept has to be -3, and so far it looks like it is. 0, -3. So that is the equation, and another way to write it would be like this. X times x to make x squared. What multiplies to make -3 and adds to -2? Yeah, very good. -3 and +1 will make that in factored form. Now, what I want you to do is look at factored form, and is there a relation between factored form and the roots? Is there a relation between those numbers? They flip the signs, right? This root value is -1, but up here it looks like it's +1. -3, +3. Why are they opposites? What do you think they're opposites for? Think about if I did put in this 3 right there, what would happen to this quantity? It would turn into 0, and 0 times anything is 0. This is why they call them zeros, because if you put this root value in, it turns the whole thing into 0, making an x-intercept. Okay? So we're looking at a basic equation here, basic x squared. What's the a value of a basic x squared? It's 1. So when a is equal to 1, we could see the opposites are the roots. The opposites inside here, these binomials, are our roots, our x-intercepts. So for our purposes in graphing these quadratic forms, we're going to mostly keep the a value at 1 or -1. All right? So our opposites will hold true on most of our graphing problems. But when we start algebraically solving, we might see some that we will have an a value lead coefficient like 2x squared or 5x squared. So it won't be as easy as the opposites. We'll have to do a little work. We'll have to set each of the binomials equal to 0 and then solve them individually. All right, we have our roots. We have a way to identify it from factored form equations. So let's go back up here and write the missing parts here. So the x minus is always there in factored form. So what's the minus tell you? Do you remember when we had to use it in our point slope form? What did that minus already in the equation tell you? It's going to be, if it's positive, it's going to be negative.
Yeah, but it's going to be multiplied by negative.
If it's going to be negative, it's going to turn into a positive. That's the opposite. they use this notation of minus as an opposite. And these values there, we're going to call them r's. Why do you think they call them r's? Yeah, roots. Root 1 and root 2. Root value 1, root value 2. All right, now let's look about symmetry. Could we use the roots to figure out where the middle is? Yeah. Look at our two values here, -1 and 3. What's the middle between these two numbers, these two x values? Positive 1's right in the middle. That's where our symmetry will be, and that makes sense. There's our vertex, x is 1. Okay? So our vertex x value and our symmetry can be found in the middle of our roots. You can almost think of it like a midpoint. Whoops. Kind of a midpoint between those x values on the x-intercepts. Another way to think about it is an average. That x value is an average of those two numbers. And how do you find the average of something? You do what? You add them all up and divide by how many things there were. So how many roots are there? There's 2 of them. Add them up and then divide by 2. Let's see if that works. -1 plus 3 is what? -1 plus 3 is positive 2. 2 divided by 2 puts us right there at 1, right in the middle. Now, if you're not too sure about this, if you can't see it spatially, you can still use -b over 2a, but you have to be in standard form to get the b value. Now, we can still graph to see all these key features, but we don't have to. We have ways now, using the forms, using the 2 different forms that we know, to find these key features. So let's practice this down here without graphing it. But remember, you can still make a table and graph it if you need to. All right, so let's look at the example, and we're looking at what form right now, right off the bat. Yeah, that's standard form. There's no parentheses. Okay, and x squared's first. All right, so in standard form, do you remember what you can see in standard form? The y-intercept, that's right. The c value over here is our y-intercepts. So let's go ahead and identify that right now. 0, 3. All right, take that off the list. We're done with the y-intercept. But now they want the x-intercepts. Can we see x-intercepts in standard form? No. We have to put this into factored form. Let's go ahead and do that. So our given equation is standard form, x squared minus 4x plus 3, and we're going to try to put it into factored form. Take a wild guess how you do that. You factor. You factor to put it into factored form. And we have a basic x squared. So it's going to be as simple as x times x, and what multiplies to make the prime number 3 and adds to -4. Good. A lot of you are saying -3 and -1. And once we have it factored, what can we see now? The roots, the x-intercepts. So our roots, roots, sometimes they'll call them zeros, like Get More Math does. And those would be just as simple as the values, 3 and 1. Just the x values. But we want to write the x-intercepts. So we got to do coordinates. So tell me the coordinates. 3, 0, and 1, 0. 1, 0. So there's our x-intercepts. Okay. Last thing to do is find what next? Our AOS. We can use negative b over 2a if you want to, but let's practice this new midpoint thing. So looking at the numbers 3 and 1, what's the middle? What's in between 3 and 1? 2. And if you add those together, divide by 2, you get the same thing. AOS has to be in between 3 and 1, right in the middle at the number 2. Last thing to do is get our vertex. We know the x value is 2, same thing as the symmetry, but how are we going to get the y value? That's right, plug it in, plug it in. So plug in the 2 into the equation. Now which one do we use? Factored form or standard form? Or does it matter? It does not matter. They should give us the same output. I'm going to avoid this little exponent. I'm going to use factored form, because I could do 2 minus 3 and 2 minus 1 pretty quickly. So doing that factored form, 2 minus 3 times 2 minus 1. Negative 1 times 1 is negative 1. And that's our y value of the vertex. Alright, so we're getting standard form, and again, we can see our y-intercept right off the bat. So let's go ahead and identify that. Y-intercept is 0, 5, 0, 5. Now we could have used negative b over 2a, but we also need the root, so why not factor it and then use both? Okay, so we're going to factor this up. Again, it's a basic x squared, so it's x times x, and what multiplies to make positive 5 and adds to negative 6? Negative 1 and negative 5. Alright, now we have factored form. We could do the opposites of the inside. So what's the opposite of negative 1?
1.
Good. And the opposite of negative 5? 5. Those are our roots, okay, or our zeros. 1 and 5. Which one's smaller? 1. Good. I hope you know that. Alright, so now 1 and 5. What number's in between 1 and 5? Right in the middle.
4.
Let's not guess. If we're not sure, we could take those numbers.
3.
It's 3, but we could take those numbers, 1 plus 5, and divide it by 2 to verify that it is going to be 3. X equals positive 3 for our symmetry. So we got our symmetry. No. Alright, now, the last thing we need is the vertex. Well, we already have half the vertex. We have the x half, 3. Again, how do you find the y of any x? Sing the song. Plug it in, plug it in. Plug in 3. Let's use it. Let's do our mental math here. This is pretty easy. What's 3 minus 1? 2. And what's 3 minus 5? Negative 2. So we're going to do 2 times negative 2 to get negative 4 for the y value. Again, we just plugged in x to get the y. And that's all of our key features. Now, we got the vertex from what form? What do we use? The symmetry and vertex. We were using factored form. Okay. What do we use for the y-intercept? We were using standard form. Alright, let's look at doing some graphing with factored form. So we're going to write down some steps, and then we will use them to graph a given equation. Alright, so these are only going to be done if you have factored form right now. Okay, if you have factored form, you could identify the roots, doing the opposites of the binomials. Okay, once you have that, your roots, then find the midpoints. Okay, that will be finding the AOS, or the same thing as the x value of the vertex. Oops, I forgot the word of. So AOS and x value of the vertex, you're going to use that midpoint of the roots. Kind of like we talked about on the graph on the previous page. So So then you have your AOS. Okay, you're going to plug that X value in. Or evaluates. Evaluate, plug in means the same thing. So plug that X value in. That's going to give you what? What part of the vertex will that give you? The Y value. I'll give you your Y value of the vertex. These are the steps we're doing anyways without graphing. All right, now we have our vertex. Let's now look at the step pattern because that's going to be very useful for graphing. So determine the step pattern very quickly here. Because when you are multiplying out to get the standard form and you see the first term, you're seeing the A value in standard form. Okay? All right, last thing, once you know the step pattern, once you have the vertex, you're going to plot the vertex. And then you're going to use the step pattern to move to the next point. Okay? Let's do these steps down below. So we look at this, and right now this is not in factored form. What form is this? Anybody know? That's right, vertex form. This is in vertex form. Okay? So we have to undo vertex form and put it into standard form before we could factor it. So that means we're going to multiply everything out. Don't forget this -1, that negative right there is a -1. So if it helps, put it down so you don't forget about it. All right, first thing I'm going to do is multiply x minus 3 squared. Is that going to be x squared plus 9? Don't fall for it. Don't fall for it. Nope. We have to expand and multiply. So -1, and if we expand and multiply x minus 3, it's going to give us x squared minus 6x plus 9. But don't forget, there's still the plus 4 over there. Now we're going to distribute to simplify this thing. -x squared plus 6x minus 9, and now we could add the 4. And now we'll have our standard form equation. What's it going to be? Plus 6x minus 5. Minus 5. Minus 5. Hey, what can we notice right now? We can see the y-intercept. What's the y-intercept? That's right. So let's go ahead and write that down. 0, -5, and let's plot that coordinate. 0, 1, 2, 3, 4, and 5. I think that's right. All right. So is that my vertex? No, that's just my y-intercept. Some random point on the problem. Not too random, I guess. All right. Now here's the trick I've never showed you before. So if haven't been paying attention, you might want to pay attention here. I've never showed you how to factor a -x squared. What we could do to make this normal x squared is get rid of the negative. We could GCF -1 out. If I GCF -1 out, it just changes all the signs. Now it's a nice positive x squared minus 6x plus 5. Why do I do that? It's so I can make it factorable. -1, and now it's a basic x squared. So x times x, we're factoring, and we already factored something like this earlier. What multiplies to make 5 and adds a -6? 5 and 1. -5 and -1. All right, so now we could finally identify what? That's right, the roots, the x-intercepts. Okay, so what are they going to be?
5.
Very good. The opposite of what we see there. So we have our roots / x-intercepts. We have our y-intercepts. Let's go ahead and plot our roots. On the x-axis, yes. Roots will always be in the x-axis. The way I remember that is think about a plant, a tree. Roots these parabolas are going to be rooted in the x-axis. That's how I remember it. All right, what's the other x-intercept? 1 and 5. So maybe you can't see it in the numbers. Maybe you cannot see what the middle number is between these two yet. But once you plot them, I think it's pretty easy to find the middle. What is it? It's going to be 3. It's going to be 3. It's going to be 3. Right in the middle is 3. Okay? So now we could write down the symmetry. AOS has to be 3 right in the middle. Draw your symmetry line. It is a part of the parabola graph, so you have to have these on there. Okay? Use your ID card or a ruler. Symmetry has to be straight. It's a straight line. It's a vertical line. Now, if I'm looking at this, could I determine right now how this opens? Is it going to go open down, like go up and then back down, or will it go down and then back up? It's going to be upside down U or regular? Yeah, it's going to be upside down. Upside down. Okay. Now, if we're not sure, we can find our vertex. So we have half the vertex. Our vertex will be 3 something. Plug in 3. And I want you to look. We have, how many forms here? We have 3 forms. We have all the forms possible of this graph. These are the 3 ways we could write this equation of a graph. This way in factored form. Okay, or we could write it in standard form or vertex form. Of these 3, and I want to plug in this number, which one will be the easiest, the most efficient? Doesn't matter which one, but I want you to think though. Which one, what form will it be the easiest to evaluate in?
It's gonna be in a vertex form.
Why vertex form? Because 3 goes right there, and what happens to 3 minus 3? Goes to 0, and 0 squared is 0, and 0 plus 4 is 4. 0 plus 4 is 4. Okay, so again, you don't have to use this one. You could use any of those forms, but don't be a robot. Look at them and go, what's going to be my easiest pathway here? Plug in 3 to vertex form. I would be looking at y equals negative 3 for my x value minus 3 squared plus 4. This goes away to 0, leaving us with just 4 for our y value of the vertex. All right, now we have that. Let's plot it and draw the parabola. There's my vertex. Okay. Hey, we haven't talked about the step pattern. What's the step pattern here? What's A? A is negative 1. So it takes the basic 1, 3, 5, and it multiplies them all by negative 1. So, what's it going to become? Negative 1, negative 3, negative 5. That means down 1, down 3, and down 5. So go to our vertex and see if it holds true. Down 1 over 1 gives me a coordinate right there. Down 3 over 1 lands me on my roots. You can do the same thing in the other direction. If I go down 5 over 1, I land on my y-intercept over there. Now let's put the problem on there. Don't judge. That's terrible. That's really bad right there. Alright, so it's telling us to write it in factored form. Again, always identify what you're given. What form is that? Standard form. That's right, standard form. That's standard form. How do you know it's standard form? There's no parentheses. That's how you know. Okay? That's how you know. Okay. So, factored form, we need to factor that equation. That's not too bad. We get nice prime numbers here. x times x. And what makes negative 3 now is negative 2?
Oh, minus 3 plus 1.
Very good, very good.
I said it first. I have it.
All right, so we have that, and now we need to identify our what from there. Now look, it's not telling you what to do. You have to remember the key features. So roots come from this one. Our roots, x-intercepts. What are they going to be? 3, 0, and negative 1, 0. Which one's smaller?
We have to put x in. Can we either say x in?
I want the coordinates.
Yeah.
Oh, on the test, I always put everything down for you because it might say one day, it might say roots on one problem. It might say x-intercepts on another problem. There's 4 ways to say it. So be aware. And if you're never sure, you can always ask me. I'll say, yes, it's an x-intercept. Okay? All right, so there's our one key feature. Oh, yeah, we forgot to say the y-intercept up here. Thank you, Johnny. Y-intercept is 0, negative 3, if I could draw negative 3. Yeah, I'm drawing on an iPad. Same thing. I could also plot my roots 3, 0, and negative 1, 0. Plotting the roots will help me determine what? The vertex and also the, that's right, AOS is going to be right in the middle. Looks like going to be what? 1, positive 1. Positive 1. Plug in 1 into any of these equations. I'm going to probably use factored form. 1 minus 3 is negative 2 times 2 is negative 4. My vertex will be 1, negative 4. 1, negative 4. And now we can see this definitely is going to be opening up. That makes sense because the A value is what? A is 1. So it's a regular old 1, 3, 5 step. And that makes sense.
Identify our step.
Up 1 over 1 is my y-intercept. Reflect it over here. Up 3 over 1 is my x-intercept. Reflect it. We already did that. All right, we have enough points. Let's go ahead and make a line. Actually, I'm going to add another coordinate. 1, 2, 3, 4, 5. That way I have more accuracy in my parabola. So you don't make fun of me so much.
What is that?
That's good.
No.
Don't laugh at that. That's not bad. It's not bad. All right, so lastly, if we are given a graph, we could use the roots to build factored form. And this is only true if we have the step pattern of A is 1, so a basic 1, 3, 5. And if we look at our graph here, we have that 1, up 1 over 1, up 3 over 1, and up 5 over 1. So it does hold true to that basic 1, 3, 5. So we could build factored form based on the opposites of what we see in our roots. So that root value right there is negative 6, and the other root value is negative 2. And we saw in factored form, the root values are the opposites of the constants inside the binomials. So we go to build factored form, x minus negative 6 times x minus negative 2. We'll simplify those to be pluses, and that'll be our equation in factored form. X plus 6 and x plus 2. And again, remind you, they call these zeros because that root value will make this quantity equal 0, and that will make the y equal 0 as well. All right, and now we remember how to get standard form from factored form. We just multiply it all out. Use a box, use distribution, whatever you need to do. And when we do that, we'll have x squared for the first term plus 8x plus 12. And now, why do we put it in standard form? It's because we could see the y-intercept. That'll help us see the y-intercept now. Or we couldn't see it on the graph. We could maybe guess it's a big positive number, but standard form tells us exactly what that number is. It's 12. So the y-intercept is 0, 12. And the last thing we can identify is the vertex straight from the graph. No equations or formulas to use. Just identify that coordinate right there. What is that going to be? 1, 2, 3, 4, -4, -4. All right, may the math be with you.